So I do think it's possible that at the moment there's one civilization in the Milky Way.
This is a huge discovery, and we think that it's a huge discovery.
The discovery of a new exoplanet has astronomers excited that it could be indeed signs of life.
Astronomers worldwide stand amazed by this groundbreaking revelation. The James Webb Space Telescope has achieved the incredible feat of capturing the faint glow of city lights a staggering 7 trillion miles away from Earth, surpassing all expectations.
Have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find because it's the nearest star to the Sun.
This extraordinary accomplishment not only broadens our understanding of the universe, but also sparks intense speculation among scientists as they meticulously analyze the data for insights into these enigmatic celestial phenomena. The implications are profound, suggesting that the universe is brimming with life and activity far beyond our current comprehension. Could these distant lights signify the presence of extraterrestrial civilizations? What implications does this hold for our understanding of life beyond Earth? Let's delve into how the James Webb Telescope recently detected city lights 7 trillion miles away. Launched into orbit on Christmas Day 2021, the James Webb Space Telescope set out to outperform its predecessor, the renowned Hubble telescope, by capturing exceptionally clear images of newly discovered celestial entities, planetary systems, and more. One of the main goals of the James Webb Space Telescope, JWST, is to investigate how the first galaxies formed by observing the farthest reaches of the universe. This is made possible because light takes billions of years to travel across the vast expanse of space. When the JWST collects light from these distant objects, it essentially provides us with a snapshot of how they appeared billions of years ago. Astronomers use light years as a unit of measurement to gauge these immense distances, representing the maximum distance light can travel in a single year. To highlight this aspect, the team chose to present a deep field image during a significant event on July 11, 2022, when US President Joseph Biden addressed the nation from the White House. Deep fields became famous when the Hubble Space Telescope focused on a tiny patch of sky for an uninterrupted period of 10 days starting on December 18, 1995. Despite covering an area equivalent to just 1/1,000,000th of the entire sky, this focused observation led to the discovery of over 3,000 previously unseen objects, the majority of which were galaxies located billions of light years away. Similar to this approach, the JWST's deep field focuses on a small portion of the sky, with its attention fixed on the SMACS 0 723 galaxy cluster. Although the galaxy SMACS 0 723 itself is 4.6 billion light-years away, its powerful gravitational field magnifies even more distant galaxies that lie beyond it. In areas where the gravitational pull is strongest, background galaxies appear distorted, forming large arcs. For example, it was calculated that light from a distant galaxy took 13.1 billion years to reach the telescope after traversing space. As the universe expands, the light emitted by these galaxies stretches. Because they are incredibly distant, the main galaxies observed by the JWST emit light that has been stretched into the infrared spectrum. By collecting data at these wavelengths, astronomers can directly compare the views provided by the JWST with visible light images of nearby galaxies captured by telescopes like Hubble. This comparison will shed light on the evolution of galaxies over cosmic time, illustrating how they have grown and merged into the structures we see today. What's even more remarkable than the sheer abundance of galaxies in the JWST's initial deep field image is the speed with which it was obtained, in mere hours rather than days. Virtually wherever it looks, the telescope finds galaxies. It's not just galaxy clusters that act as cosmic magnifying glasses. Scientists also used the JWST to image a pair of galaxies known as VV 1191. Allowing them to study how the light from one galaxy changes as it passes through the other. The findings from this study will unveil the characteristics of the intervening galaxy's dust. It seems like the JWST may have made a groundbreaking discovery in a distant region outside our solar system. The announcement of potential auroras on a brown dwarf came directly from the official JWST website. The absence of a central star and the extremely cold temperatures pose challenges in determining the source of energy in the upper atmosphere. However, scientists believe that methane emissions from the object might be responsible for the auroras. To simplify on Earth, auroras are formed when energetic particles from the Sun get trapped by our planet's magnetic field and collide with gas molecules in the atmosphere, creating the mesmerizing phenomenon known as the Northern Lights. Jupiter and Saturn also exhibit similar auroras due to interactions with the solar wind. However, the brown dwarf W1935 lacks a central star to orbit, making its auroras a perplexing puzzle. Much anticipation is placed on Proxima Centauri b, a mere 4.24 light-years away within the Milky Way galaxy. Scientists have detected water on this exoplanet, raising the tantalizing possibility of life beyond Earth. Could this be the long-awaited evidence of extraterrestrial life? Just last month, the JWST made yet another remarkable discovery: a supermassive black hole with a reddish hue, voraciously consuming everything in its vicinity. This colossal find is a staggering 40 million times the size of the Sun. But what implications does this discovery hold for us, knowing that the JWST has detected another supermassive black hole that has been present since the universe's inception? It may not bode well. This cosmic behemoth is swiftly engulfing everything nearby. Leading the investigation are Dr. Lucas Ferto and Professor A.I. Zitrin from Benin University of the Negev in Israel. Their findings reveal that this supermassive black hole is roughly 40 times more massive than the Sun, making it an immense entity compared to the galaxy it inhabits. Fortunately, it poses no immediate threat to Earth or our solar system, situated at a vast distance of 12.9 billion light-years away. However, the black hole's relentless consumption of its surroundings is bringing it closer to us at an alarming pace. The reddish hue it emits indicates that it is shrouded in a thick veil of dust, obscuring much of the light passing through. When the JWST initially transmitted its data, scientists were thrilled to sift through the findings of the Uncover program. Among the data, 3 small objects emitting a crimson glow captured our attention. We immediately suspected that it might be a quasar-like object, which are supermassive black holes found at the centers of galaxies, constantly drawing in surrounding material. The appearance of a small red dot suggests that the entire galaxy's brightness couldn't possibly be confined to a spot no larger than a modern star cluster. Through gravitational lensing, we were able to obtain highly precise size estimates for the source. Even when considering the possibility that all potential stars are condensed into this tiny area, the black hole still makes up at least 1% of the system's total mass. Discovering similar behavior in numerous other supermassive black holes from the early universe has provided valuable insights into their growth, as well as that of their host galaxies. It also sheds light on the interaction between the two, which remains largely mysterious to astronomers. Whether supermassive black holes originate from remnants of stars, or perhaps from ancient cosmic material that collapsed into black holes, remains an unanswered question in astronomy. In addition, the James Webb Space Telescope has been uncovering some rather intriguing phenomena in the images it sends back to Earth. Each night, we're treated to the awe-inspiring sight of distant planets and stars twinkling across the vast expanse of the universe, spanning countless light years. What's more, the James Webb Space Telescope expands our vision beyond what our eyes can perceive, revealing unexpected wonders such as a peculiar formation resembling a question mark in space. For over 20 months now, the Webb telescope has been gracefully traversing through space, capturing and transmitting images of the deep cosmos using its cutting-edge near-infrared camera. Recently, attention has been drawn to a curious feature spotted in one of Webb's images. While the focus was on two young stars forming approximately 1,470 light-years away from Earth, an intriguing orange mark resembling an inverted question mark appeared at the base of the image. Despite its diminutive appearance in the picture, the mark is actually quite sizable. It was observed while studying the pair of young stars known as Herbig-Haro 46 to 47, surrounded by expansive disks of dust and gas, indicative of their youthful age of just a few thousand years. As for the peculiar shape resembling a question mark, it's speculated that this is a result of the two-dimensional nature of the image presented by Webb from its particular perspective. At present, the true nature of this enigmatic feature remains a mystery, and without further investigation, it may remain so indefinitely. However, the findings have undergone thorough scrutiny by experts in the field, leading to the conclusion that it's most likely a distant galaxy, or perhaps multiple galaxies interacting with each other. The distorted shape resembling a question mark could be a consequence of these interactions. It's entirely possible that this phenomenon has never been observed before. To definitively identify its nature, further investigation is essential. With the James Webb Space Telescope unveiling a multitude of distant galaxies, there's ample opportunity for new scientific inquiries. All eyes, our attention is directed towards a specific group of Earth-sized planets that could potentially harbor extraterrestrial life right in our cosmic neighborhood. This quest could hold the key to resolving the Fermi paradox, which questions the absence of evidence for advanced alien life despite the high likelihood of its existence. Where are these planets located? They orbit a star named TRAPPIST-1, situated approximately 40 light-years away from Earth and our solar system. TRAPPIST-1 boasts a remarkable 7 planets orbiting around it. In NASA's pursuit of habitable planets, a multitude of factors are taken into consideration. Beyond just a planet's size and its distance from its parent star, researchers now focus on identifying the presence of specific compounds in a planet's atmosphere. This approach offers a more effective means of determining a planet's habitability potential. 6 years ago, the Infrared Spitzer Space Telescope, as part of NASA's exploration efforts, played a pivotal role in the discovery of 7 rocky exoplanets orbiting a single star known as TRAPPIST-1. Now, the James Webb Space Telescope has successfully gauged the temperature of TRAPPIST-1b, one of these intriguing worlds. The JWST continues to make significant strides since its inception, with this latest revelation marking yet another milestone in its impressive track record. This groundbreaking discovery represents the first instance of detecting any form of light emitted by an exoplanet as small and cool as the rocky planets within our own solar system. Previous telescopes lacked the sensitivity required to measure such faint mid-infrared emissions. Astronomers were understandably thrilled upon learning about the 7 TRAPPIST-1 exoplanets, as these distant worlds share similarities with Earth in terms of size and orbit within the habitable zone, the region around a star where planets have the potential for liquid water on their surfaces at an optimal distance. Described as an extraordinary laboratory by scientists, the TRAPPIST-1 system presents a unique opportunity to study the atmospheres of rocky planets. Its proximity and the characteristics of its planets make it one of the most promising locations for advancing our understanding of exoplanetary atmospheres. While the discovery of the TRAPPIST-1 planets is undoubtedly fascinating, it's essential to temper our excitement regarding the prospect of these worlds as potential habitats for humans. Located a staggering 235 trillion miles away, these planets remain far beyond our current reach. Furthermore, they orbit a star considerably smaller and redder than our Sun, known as an M-dwarf star. These M-dwarfs are abundant in the Milky Way, being 10 times more prevalent than Sun-like stars, and they exhibit a higher likelihood of hosting rocky planets. These characteristics make them prime targets for scientists searching for habitable planets, as rocky planets orbiting M-dwarfs are more readily observable. However, there's a significant caveat. M-dwarf stars are notably more active than our Sun, frequently experiencing flares and emitting high-energy radiation. These phenomena could potentially pose risks to any emerging extraterrestrial life or the stability of a planet's atmosphere. Previous observations of TRAPPIST-1b lacked the sensitivity required to definitively determine its atmospheric composition or whether it was a barren, rocky world. Being tidally locked to its star means that one side of the planet always faces the star, while the other remains in perpetual darkness, a phenomenon predicted by simulations. If TRAPPIST-1b possessed an atmosphere, it would moderate the planet's temperature by redistributing heat across both hemispheres. However, measurements taken by the JWST indicate a significantly higher temperature, effectively ruling out the presence of an atmosphere and eliminating another candidate from the roster of potentially habitable worlds. However, what truly ignites our excitement is not solely TRAPPIST-1b itself, but rather the capability of the JWST to conduct such groundbreaking observations. This opens the door for us to explore the atmospheres and climates of countless other worlds. What wonders might life on these planets hold? Once again, the James Webb Space Telescope steps into the role of extraterrestrial meteorologist, venturing into the realms of space exploration. This cutting-edge piece of space technology has been harnessed by an international team of astronomers eager to unlock its potential across the cosmos. It marks the latest chapter in a brief yet illustrious history of cosmic discovery, which includes capturing images of a nearby moon that eerily resembles Earth. This journey is only the beginning of its galactic quest for treasure. When it comes to understanding weather patterns, the JWST has been meticulously mapping the atmospheric conditions of a colossal planet located some 280 light-years away. That's an astonishing distance of roughly 464 trillion miles from Earth. Dubbed WASP-43b, this planet is comparable in size to Jupiter and earned the nickname Hot Jupiter from NASA after its discovery by the Hubble Space Telescope in 2011. The weather forecasts have unveiled scorching temperatures of 1,250 degrees Celsius and equatorial winds, racing at speeds exceeding 5,000 miles per hour. These phenomena were previously concealed beneath thick layers of dense clouds blanketing the planet's dark side. This occurrence is attributed to the tidal locking of WASP-43b, where one side always faces the nearest star, while the other side remains perpetually shrouded in darkness. By meticulously combining precise measurements of brightness across a broad spectrum of mid-infrared light with sophisticated 3D climate models and previous observations from other telescopes, the JWST successfully confirmed the presence of water vapor on the day side of WASP-43b. Additionally, indications from both the Spitzer and Hubble telescopes hinted at the potential existence of clouds on the planet's night side. However, more precise data from the JWST was required before we could delve into mapping the planet's climate, cloud cover, wind patterns, and atmospheric composition on a regional scale. WASP-43b completes a full orbit around its star in approximately 19.5 hours, allowing the JWST to detect subtle fluctuations in brightness exhibited by the planet and its neighboring celestial bodies. Utilizing the advanced capabilities of its near-infrared camera, the JWST analyzed changes in brightness to deduce the planet's temperature. The amount of mid-infrared light emitted by an object correlates strongly with its temperature, making these measurements crucial for the accuracy of the findings. Over a period of more than 24 hours, measurements were taken every 10 seconds, enabling the derivation of a rudimentary map depicting the planet's temperature across its entire orbit. This comprehensive dataset enabled scientists to ascertain the varying temperatures of different regions of the planet as they rotated into view. The side of the planet perpetually bathed in sunlight boasts an average temperature of nearly 2,200 degrees Celsius, 182 degree F, a scorching heat capable of liquefying iron and most other metals. On the dark side, temperatures are notably cooler, but still scorching at approximately 1,112 degrees Fahrenheit. However, the presence of methane, a stable and easily detectable gas, is notably absent due to the rapid circulation of heated air caused by supersonic winds. This ability to map temperatures in such detail is a testament to the remarkable sensitivity and stability of the JWST. The absence of methane leads scientists to infer that WASP-43b is subject to winds exceeding speeds of 5,000 miles per hour. At such intense velocities, chemical reactions necessary for methane production cannot occur quickly enough to generate detectable quantities on the night side. Additionally, shortly after the remarkable discovery at the universe's infancy, attention has now turned to a distant planet named K218b, which is approximately 8 times the size of Earth. This planet orbits a cooling dwarf star known as K218, located some 120 light-years from Earth. Researchers examining K218b have identified a gas that, to our current understanding, can only be produced by living organisms, a truly intriguing development in the quest for extraterrestrial life. Although K218b lacks ammonia, it boasts an abundance of other chemical elements found on Earth, including carbon dioxide and methane. This chemical composition has led astronomers to contemplate the existence of ocean exoplanets, speculated to be covered by vast oceans and enveloped in hydrogen-rich atmospheres. The insights provided by JWST observations have been instrumental in advancing our understanding thus far. Initial observations by the Webb telescope also hinted at the potential presence of a molecule called dimethyl sulfide, DMS, a substance typically associated with biological activity. On Earth, DMS is primarily emitted by phytoplankton in marine environments. However, it will be several months before we receive the results of the new tests conducted by the JWST, as they undergo rigorous analysis, peer review, and eventual publication. Since its initial identification 9 years ago, K218b has been subject to ongoing scrutiny. Over this period, water vapor was detected in its atmosphere, and most recently, the JWST reported the presence of carbon dioxide and methane. Despite lying within the habitable zone of its star, there's no guarantee that K218b can support life. Currently, researchers maintain a level of certainty exceeding 50% regarding the presence of DMS on Earth. While this level of certainty falls short of definitive proof, it fuels optimism and anticipation for future discoveries. The implications of this discovery might not be reassuring for us. Voyager 1, the spacecraft that has ventured farthest from Earth, has encountered something perplexing beyond our solar system's borders. This recent development has left physicists puzzled as the spacecraft has entered an unfamiliar zone at the frontier of the solar system, surpassing previous expectations. NASA initially anticipated that Voyager's transition into this new region, where galactic influences become more prominent, would be gradual and unremarkable. However, it has proven to be far more intricate and challenging than anticipated, as the spacecraft encounters an enigmatic area that experts are struggling to comprehend. Throughout their remarkable 46-year journey, the Voyager missions have played a crucial role in uncovering the true nature of our solar system for the scientific community. However, it was never envisioned that these missions would endure for so long. The concept of sending out probes in the 1970s emerged serendipitously when Michael Minovich recognized the potential for a spacecraft to harness a planet's velocity and venture deeper into the solar system. This realization laid the groundwork for the initial plans of the Voyager probe. Originally slated for a 5-year mission, according to NASA officials, Voyager 1 and Voyager 2 continue to journey through space, gathering invaluable scientific data from the farthest reaches of our universe. Launched just weeks apart in the summer of 1977, the Voyager 1 and Voyager 2 missions were initially designed to explore Jupiter and Saturn. Both missions successfully completed their studies of these gas giants. Voyager 2, then made historic close-up observations of Neptune in 1989 and Uranus in 1986, marking the first ever encounters with these distant planets. Collectively, these flybys of the four outer planets were known as the Voyager Grand Tour. Subsequently, both spacecraft embarked on extended missions to explore remote regions of space. In 2013, NASA announced a significant milestone. Voyager 1 had crossed the boundary between our solar system and interstellar space. Interstellar space refers to the vast distances between stars, beyond the influence of our Sun's magnetic field, and the continuous stream of particles known as the solar wind. 5 years later, in 2018, Voyager 2 followed suit, marking its entry into interstellar space. At the time of its departure, the spacecraft had traveled a staggering 11 billion miles from Earth. To date, the Voyager missions remain the only spacecraft to have ventured into interstellar space. Together, these pioneering explorers have provided invaluable insights into how charged particles from the Sun, known as the solar wind, interact with the space environment. They have also shed light on the heliosphere, the protective bubble that surrounds our solar system. Formed by the solar wind, the heliosphere undergoes alterations and influences from interstellar conditions. NASA highlights that the Voyager spacecraft have yielded novel discoveries about interstellar space. For instance, they revealed that cosmic rays are approximately 3 times more intense outside the heliopause, the boundary of the heliosphere, than within it. Scientists have integrated Voyager's observations with data from subsequent missions to enhance our understanding of the interactions between our solar system, the heliosphere, and the surrounding interstellar space. According to NASA, Voyager 1 detected a peculiar buzzing noise attributed to waves captured in trace amounts of gas present in the predominantly empty interstellar medium. Throughout their mission, the Voyager spacecraft have provided invaluable insights into our Sun and its impact on our solar system. Despite operating in temperatures significantly lower than their original design parameters, experts remain puzzled by the Voyager's remarkable resilience. Additionally, researchers have uncovered intriguing phenomena beyond the boundaries of our solar system. While Voyager 1's plasma temperature measurement device ceased functioning in 1980, Voyager 2's instrument remained operational, offering a clearer perspective of the heliopause during its passage on November 5, 2018. This marked the first time scientists could observe the behavior of plasma as it approaches the heliopause, noting that it slows down, heats up, and becomes denser. Surprisingly, at a distance of 140 million miles, the interstellar medium on the opposite side of the boundary registers temperatures exceeding 54,000 degrees Fahrenheit, surpassing initial expectations. However, the average temperature surrounding the Voyager probes remains relatively low. Given the thin and diffuse nature of this plasma, the heliopause acts as a porous barrier, facilitating bidirectional flow of particles, as reported by Voyager 2. While Voyager 1 encountered interstellar particles penetrating the heliopause like tree roots through rock formations, Voyager 2 observed a thin stream of low-energy particles extending over 100 million miles past the heliopause. These observations shed light on the complex dynamics at play in the boundary regions of our solar system and the interstellar medium. As Voyager 1 neared the heliopause by approximately 800 million miles, it encountered a puzzling phenomenon, an area reminiscent of limbo, where the outward solar wind slowed to a near halt. Meanwhile, Voyager 2 observed a distinct layer of solar wind forming before crossing the heliopause, surprisingly mirroring the width of the static layer observed by Voyager 1. Prior to the Voyager missions, astronomers hypothesized that the solar bubble would gradually dissipate into interstellar space as one moved farther from the Sun. However, Voyager 2's observations suggest the presence of a discernible barrier in this region. The plasma densities measured by Voyager 1 and Voyager 2 using their plasma wave instruments were remarkably similar. As one crosses the boundary between the hot solar plasma and the cold interstellar plasma, plasma density increases significantly, exhibiting fluid-like behavior and creating sharp boundaries. Most notably, scientists were taken aback by the identical relative distances of both Voyager spacecraft from the heliopause. Previous models had predicted that increased solar activity during Voyager 1's 2012 flyby would cause the heliopause to extend further, while Voyager 2's passage during a period of low solar activity in the following year would result in its closer proximity to the heliopause. This discrepancy has led to some confusion regarding the spacecraft's departure from the solar system at two different locations but similar distances. Furthermore, Voyager 2's observations have raised questions about the existence of a sharp border. Notably, discrepancies were observed in the magnetic field measurements both inside and outside the bubble, contrary to astronomers' predictions regarding the orientation of the magnetic field between the two regions. While navigating this delicate boundary, both Voyager 1 and Voyager 2 observed minimal fluctuations in the magnetic field direction. However, measurements from Voyager 2 suggest it encountered a heliopause that was less intricate and less densely populated with lower energy particles compared to what Voyager 1 encountered. Yet, these findings raise more questions than they answer. The broader solar system is significantly impacted by coronal mass ejections, powerful eruptions of plasma frequently emitted by the Sun. Interestingly, it seems that the Sun's influence extends beyond its immediate vicinity. Data from Voyager 1 and Voyager 2 indicates that coronal mass ejections extend beyond the heliopause, diminishing cosmic ray flux in the surrounding interstellar medium. This phenomenon bears resemblance to how supernovae disrupt the interstellar medium on a galactic scale, potentially influencing the formation of stellar systems like our own. These findings lend credence to the notion that the Sun's activity could influence the development of life on other planets, both within our solar system and beyond. Considering the potential impact of cosmic rays on biological mutations on Earth, continued analysis of the Voyager mission's data will deepen our understanding of the interactions between the Sun's heliosphere and interstellar space, providing insights into other stellar systems as well. However, our comprehension of the heliosphere remains incomplete. Both Voyager 1 and Voyager 2 departed the heliosphere near its leading edge upon encountering the interstellar medium. Unfortunately, we lack sufficient data to accurately determine the shape of the heliosphere's wake. While it may be roughly spherical due to the pressure exerted by the interstellar medium, it is also plausible that it exhibits comet-like or croissant-like characteristics. A more comprehensive understanding of the heliosphere is essential to unravel these lingering mysteries. However, with other spacecraft venturing beyond our solar system, they won't be able to match the speed of Voyager probes, which travel at over 31,000 miles per hour. NASA's New Horizons spacecraft is one such example, currently departing the solar system. However, by the 2030s, it will exhaust its power reserves, falling short of reaching the outer boundary of the heliosphere by over 1 billion miles. Consequently, researchers involved with Voyager missions and others are advocating for another interstellar mission. This proposed Mission 50 Inches would involve multiple generations of spacecraft, aimed at studying the outer reaches of the solar system before venturing into unexplored territories beyond the influence of the solar wind. Nevertheless, the observations at the heliopause nearly marked the conclusion of both Voyager spacecraft. Solar power is impractical in the vast expanse of outer space, far removed from the Sun. To address this, engineers equipped each Voyager with 3 radioisotope thermoelectric generators, RTGs, which derive energy from the heat generated by plutonium-238, a radioactive fuel. These RTGs essentially act as nuclear batteries, steadily losing power at a predictable rate of 4 watts per year. While the Voyagers require minimal power for propulsion, it is crucial for them to continue gathering scientific data on distant magnetic fields and charged particles. Currently, they represent humanity's only means of obtaining such data in interstellar space. NASA initiated efforts to prolong the operational lifespan of the Voyager probes several years ago. In 2019, the first measure involved gradually turning off the heaters for the scientific instruments. Remarkably, despite a temperature reduction of 122 degree F, far colder than the tested conditions, the instruments continued to function. However, this adjustment alone proved insufficient. Consequently, in late March, a team from NASA implemented an energy-saving technique on Voyager 2, utilizing backup power to shield systems from sudden voltage spikes. Unfortunately, Voyager 1 ceased transmitting data to Earth in November of the previous year, indicating a halt in both engineering and scientific transmissions. Addressing issues with the universe's most remote spacecraft isn't a simple task. The sudden loss of communication left NASA puzzled, as the probe was relaying crucial data about interstellar space. Positioned 15 billion miles away and hurtling at 32,000 miles per hour, commands from mission controllers take approximately 22.5 hours to reach the distant probe. Subsequently, an equal amount of time is required for a response. NASA has been troubleshooting the issue for over 5 months. Initially, the plan in March was to stimulate the spacecraft digitally, akin to a dentist using air puffs to detect dental issues. Engineers sent a command instructing Voyager to transmit a complete memory readout to Earth, pinpointing any malfunctioning components. The Flight Data Subsystem, one of Voyager's 3 onboard computers, manages the packaging of science and engineering data for transmission. It was within this subsystem that the reported malfunction was identified. Due to the glitch, the computer was generating repetitive binary code, indicating a stalled state rather than transmitting valuable scientific, temperature, and engineering data. Since the damaged chip couldn't be replaced, NASA devised a clever workaround, relocating the problematic code to another area within the Flight Data Subsystem memory. However, due to the complexity of the code and the limitations of individual memory locations, this process presented its own challenges. To tackle this, they developed a strategy to divide the affected code into manageable sections and move these sections within the computer system's memory while ensuring continued communication and collaboration. With this innovative approach, NASA's Jet Propulsion Laboratory has officially announced Voyager's return to service, marking one of the most remarkable long-range software updates in history. Now, we eagerly anticipate the arrival of scientific data from Voyager 1 in the coming weeks. While the exact cause of the malfunctioning chip remains unknown, the team suspects it may have been damaged by an energetic particle from space or simply worn out after 46 years of operation. While Voyager 1 primarily studies cosmic rays, scientists are also intrigued by an anomaly they've dubbed Pressure Front 2, characterized by an increase in plasma density and magnetic field around the spacecraft. NASA remains uncertain whether this phenomenon originates from the solar system or interstellar space. Meanwhile, NASA recently provided an update on Voyager 2's troubleshooting. The first indications of a problem arose during a scheduled rotation maneuver intended to calibrate its magnetic field instrument. However, the craft's inability to complete the rotation led to the prolonged activation of 2 power-intensive systems, resulting in excessive power consumption. Given Voyager 2's limited power supply, it employs strict power management measures, shutting down non-essential systems, including scientific instruments, to preserve essential functions as its fuel degrades over time. Following the failed rotation maneuver, Voyager 2 deactivated its scientific instruments, rendering it incapable of gathering new data. Given the spacecraft's considerable distance from Earth, where commands take 17 hours to reach and another 17 hours for the ground team to receive its response, engineers faced a daunting challenge in troubleshooting the issue remotely. Despite these hurdles, the team successfully restored Voyager 2's instruments to full functionality. With all systems operational once again, Voyager 2 is poised to resume its mission of exploring the vast expanse between stars and documenting its surroundings. Voyager 2's distant position from extraterrestrial beings invites speculation about its encounters. But what's fact and what's fiction? To grasp the immense distance between Voyager 2 and Earth, consider that commands sent from our planet require 13 hours to reach the spacecraft. The emergence of a potential issue with the probe only became apparent in late 2021, sparking widespread speculation, particularly among conspiracy theorists. Some suggest that extraterrestrial beings intercepted Voyager 2 and tampered with its communication abilities. While some dismissed this notion outright, a German expert insists that such a glitch could only result from alien intervention. The UK's The Telegraph even entertained these rumours, amplifying the claims of a UFO expert without providing counter-arguments from credible space authorities. While the most plausible explanation points to a programming error, the allure of the alien hypothesis ensures that this theory will persist in discussions for the foreseeable future. For decades, NASA spacecraft have been beaming messages into the cosmos, and a recent study sheds light on when we might expect responses to these signals. Researchers from California examined several notable probes from the US Space Agency, including Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. These spacecraft have been instrumental in gathering vital data about the universe, facilitated by deep space radio antennas that transmit signals into space, reaching far beyond our own solar system. The authors of the study, Riley Derrick and Howard Isaacson, explained that these transmissions have traversed vast distances, encountering other stars along the way. This raises the intriguing possibility that intelligent life in distant solar systems might intercept our terrestrial transmissions. Through their analysis, Derrick, Isaacson and their team pinpointed areas where such extraterrestrial civilizations could potentially receive and respond to our signals, offering insights into the timing and location of these potential contacts. According to their findings, if there's an advanced civilization residing near a white dwarf, we could receive a response as early as 2029. Additionally, signals from Voyager 2 reached both an M dwarf and a brown dwarf in 2007, suggesting a potential return signal by 2033. Meanwhile, Voyager 1 is embarking on ambitious journeys, projected to make contact with 277 stars by 2341, with its transmissions reaching the first star in 2044. The chances of US receiving a response to these signals are heightened by the realization that it's not just stars that will intercept them. As reported by Derrick and Isaacson, they've concluded that planets orbiting the stars contacted will also receive messages from the spacecraft. And now, we wait. This isn't merely another anomaly, it's a mystery beckoning to be unraveled, a puzzle whose pieces elude understanding. In the vast silence of space, where stars shimmer like distant beacons of possibility, a NASA satellite has stumbled upon something startling nestled between our planet's azure expanse and the enigmatic veil of Venus. Some speculate about encounters with extraterrestrial beings or the unearthing of remnants from advanced civilizations. Others ponder gravitational anomalies rippling through space-time as data streams in, painting a portrait of cosmic disorder. At NASA, scientists hold their breath, contemplating the mysteries concealed within the void of space and the potential secrets it might harbor. Join us as we delve into the enigmatic realm between Earth and Venus, a truth that could forever alter our journey among the stars. In the turbulent atmosphere of Venus, astronomers on Earth have detected signs hinting at the possibility of life. Venus, named after the Roman goddess of beauty, roasts at temperatures soaring into the hundreds of degrees, veiled by clouds laden with corrosive sulfuric acid droplets. While few have considered the rocky planet a suitable habitat for life, scientists have long focused their search for extraterrestrial life on other celestial bodies, notably the icy moons of the gas giants like Europa and Enceladus, as well as Mars itself. Astronomers haven't physically retrieved samples of microbes from Venus, nor captured any visual evidence of their existence. However, through the use of powerful telescopes, they've detected a chemical known as phosphine in the dense atmosphere of Venus. After thorough analysis, scientists posit that the presence of a living organism is the most plausible explanation for the origin of this chemical. On the flip side, there are scientists who remain skeptical of this theory, suggesting that the gas could potentially stem from some mysterious aspect of the planet's atmosphere or geological processes. This discovery may prompt some planetary scientists to ponder whether we have overlooked a planet that was once more Earth-like than any other in our solar system. Venus, often hailed as one of the most captivating objects in Earth's night sky, reveals a less enchanting reality upon closer examination. Despite its nearly identical mass to Earth, Venus is often referred to as Earth's twin planet. Some scientists speculate that in the past, Venus might have possessed an atmosphere conducive to supporting life akin to our own. During the earlier stages of the solar system's evolution, Earth wasn't exactly a hospitable environment for life as we know it today. However, evidence suggests that life did exist here in some form, even thriving in a biosphere that eventually succumbed to the development of an oxygen-rich atmosphere. Just as Earth evolved to become a diverse habitat for various life forms, something transformed Venus into a harsh, inhospitable environment, starkly contrasting with the vibrant ecosystems found on our own planet. The second planet from the Sun, Venus, harbors an atmosphere choked with carbon dioxide gas, where surface temperatures soar to an average of over 800 degree F. The atmospheric density of Venus exerts immense pressure, surpassing 1,300 pounds per square inch on anything at its surface, over 90 times the atmospheric pressure at sea level on Earth, equivalent to the pressure experienced at depths of 3,000 feet underwater in the ocean. It's a harsh environment that poses significant challenges for exploration and research, despite numerous attempts. Several robotic missions to Venus, including several from the Soviet Union's Venera series, have been launched. But many of these spacecraft met their demise quickly upon landing as the planet's harsh conditions rapidly corrode metal. Only 2 missions successfully captured direct images of the planet's surface. Despite Venus's blistering surface temperatures, there exists a cloud layer at a relatively mild 86 degree F and a pressure akin to Earth's ground level just 31 miles below the surface of its atmosphere. Over the years, a number of planetary scientists, including Carl Sagan and Harold Morowitz, have pondered the potential for life on Venus. In June 2017, astronomer Jane Greaves from Cardiff University in Wales embarked on a mission to investigate this possibility using the James Clerk Maxwell Telescope in Hawaii. Her aim was to search for traces of various chemicals on Venus, employing radio waves of different wavelengths to penetrate the planet's clouds. Different molecular species absorb radio waves at characteristic wavelengths, offering insights into the chemical composition of Venus's atmosphere. Unexpectedly, one of the chemicals Greaves detected was phosphine, a compound consisting of 1 atom of phosphorus and 3 hydrogen atoms arranged like a pyramid. This discovery was surprising, given that phosphine had previously been detected in the atmospheres of gas giants like Jupiter and Saturn by NASA's Cassini spacecraft. Dr. Sousa Silva explains that the formation of phosphine doesn't necessarily require the presence of life. The extreme heat and pressure on planets like Venus can force phosphorus and hydrogen atoms to combine, creating the molecule. However, the scientists argue that smaller rocky planets such as Venus and Earth lack the necessary energy to produce significant amounts of phosphine. Conversely, anaerobic organisms or microbes that don't rely on oxygen for survival seem to be particularly adept at generating phosphine. Yet, based on current knowledge, it appears that only life can produce phosphine on such worlds. Dr. Silva has long explored the gas theoretically, hoping that its detection as an emission from rocky exoplanets orbiting other stars could offer evidence of extraterrestrial life. On Earth, phosphine is found in various environments, including the intestines of animals like penguins and badgers, as well as in some deep-sea worms. It's also highly toxic and has been utilized in chemical warfare and agricultural fumigation. In popular culture, it's even depicted in the TV show Breaking Bad, where the main character, Walter White, uses it to eliminate rivals. However, despite its prevalence, the origins of phosphine production by Earth's bacteria remain puzzling. Matthew Pace, a geoscientist at the University of South Florida in Tampa, notes the lack of understanding regarding its sources and formation mechanisms. Although phosphine has been observed in association with microbial activity, direct evidence of microbes producing it is still elusive, a subtle yet significant distinction in our quest to comprehend this enigmatic molecule. In March 2019, the scientific team employed the Atacama Large Millimeter Array in Chile, a more powerful telescope, for their investigation. Contrary to their expectations, they not only detected phosphine, but found it in significant quantities, ranging between 5 and 20 parts per billion. These concentrations are millions of times higher than those found in Earth's atmosphere. While these amounts might seem small over a year, the researchers used computer simulations to model Venus's atmosphere and explore potential sources and levels of phosphine. Since phosphine is continuously broken down by light, it must be replenished frequently. However, the team concluded that Venus's volcanic activity and lightning would be insufficient to sustain the observed levels of phosphine, suggesting that living organisms could be responsible for its production. This discovery aligns with previous detections of gases on other planets that could be indicative of life. However, gases like methane or oxygen detected on Mars can also arise from non-biological chemical reactions. Thus, while intriguing, these findings do not yet serve as conclusive evidence of extraterrestrial life. The presence of phosphine on Venus raises questions about the type of life forms that could produce it within the planet's clouds. Any such organisms would need to adapt to survive in an acidic environment, possibly developing protective shells akin to those found in extremophiles inhabiting harsh climates on Earth. Microbes suspended in gravity waves could conceivably thrive, metabolize, and multiply within sulfuric acid and water droplets. According to Dr. Seeger and her colleagues, such bacteria could be abundant contributors to phosphine production in Venus's atmosphere. When considering the possible origins of these bacteria, Dr. Seeger speculated that they might have initially emerged on Venus's surface during its ancient oceanic era, which occurred up to 700 million years ago. However, as the planet's oceans dried up, these organisms could have been propelled into the atmosphere. Whether these bacteria, if they indeed exist, share any genetic similarities with life on Earth or possess a completely unique genetic makeup remains an open question. Dr. Seeger emphasized the inherent Earth-centric perspective in the search for extraterrestrial life, as Earth serves as our sole point of reference. Consequently, researchers are eagerly awaiting additional data from telescopes and refining their models before entertaining speculative hypotheses. One potential avenue for advancing this search involves sending robotic missions to Venus, which could provide valuable insights. Over the past 2 decades, our prospects for discovering life beyond Earth have significantly improved, thanks to a continuous stream of new discoveries. Few scientists would have anticipated Venus playing such a pivotal role in this quest. Yet, Venus has emerged as a captivating focal point for exploration, joining a growing list of intriguing celestial bodies. While inquiries into topics like galaxy formation and the enigmatic nature of black holes are undoubtedly monumental in the annals of scientific inquiry, our solar system also harbors profound mysteries waiting to be unraveled. Studying the planets and moons within our cosmic neighborhood not only expands our understanding of the universe, but also fuels our imagination about the boundless possibilities that lie beyond. Discoveries of potentially habitable planets, such as Mars, amidst otherwise harsh environments, offer valuable insights into the prevalence of life within our solar system and beyond. Understanding the factors contributing to the demise of once vibrant worlds like Venus can provide clues about the frequency of planetary extinctions around distant stars. By delving into these intriguing mysteries of our solar system, we not only deepen our understanding of our own existence, but also contemplate our purpose, the remaining time on Earth, and the legacies we may leave behind. Prior to the Apollo moon landings, scientists held a certain understanding of the moon's formation process. It was commonly believed that the moon formed from residual material left over from the sun's formation, akin to the process by which planets were formed. However, the analysis of rock samples brought back by Apollo astronauts revealed a completely different narrative. Geologists discovered that the moon's surface was dominated by a unique type of rock known as anorthosite, which contributes to its distinctively bright appearance in the night sky. This finding suggested that the moon's formation involved intense heat and magma activity, indicative of a cataclysmic event. The specifics of this event remain a mystery, yet it paints a vivid picture of a dramatic and transformative epoch in the moon's history. Could Earth have harbored an advanced civilization in the past? Is there intelligent life beyond our planet's boundaries? These age-old questions continue to intrigue scientists. Astronomer Adam Frank and climate scientist Gavin Schmidt take a unique angle, pondering the existence of intelligent beings in Earth's ancient history. Might there be remnants of a sophisticated non-human culture buried within Earth's layers, dating back hundreds of millions of years? While this inquiry extends far beyond our solar system, its implications are cosmic in scale. Schmidt and Frank raise a fundamental query. What are the chances that any intelligent life, anywhere in the universe, leaves behind traces of its existence? Furthermore, if humanity were to vanish, could future extraterrestrial visitors detect any signs of our presence? Moreover, could there be a hidden ninth planet lurking in the outer reaches of our solar system? Pluto's demotion from planet status in 2006 by the International Astronomical Union left our solar system with 8 recognized planets. However, recent evidence suggests the possibility of a genuine ninth planet beyond Neptune's orbit, influencing distant objects through its gravitational pull. Despite astronomers' confidence in its existence, this elusive planet has yet to be directly observed. Can these clues lead us to the discovery of a true ninth planet? Perhaps, but the challenge lies in locating it amidst the vastness of space. It's akin to searching for a single black grain of sand on a vast beach, a daunting task that exemplifies the difficulty of finding Planet 9. Nonetheless, astronomers continue to unearth extrasolar planets in the most unexpected corners of the universe. Beyond the scorching gas giants that orbit their stars closely, there are also terrestrial worlds akin to Earth, meandering around various suns, as well as nomadic rogue planets traversing the galaxy freely. A colossal yet faint brown dwarf, a type of failed star, is now observed to host a planet reminiscent of Venus, thanks to astronomers utilizing gravitational lensing. This intriguing find offers insights into the formation of planets and moons, potentially aiding in the quest for habitable worlds, including moons conducive to life or Earth-like planets. This doesn't confirm anything definitively, but it provides the initial suggestion of a commonality in the formation of companions across different scales, explains Andrew Gould from Ohio State University. When nascent stars emerge from the gravitational collapse of cold gas and dust clouds, they are ensconced within swirling disks of residual material. Planets take shape as dense pockets within these disks coalesce. Similarly, it's theorized that Jupiter's largest moons formed from a circumstellar disk surrounding the gas giant during its infancy. In contrast, brown dwarfs occupy a unique niche, not quite stars, yet not fully fledged planets, as they lack the mass required for sustained fusion like stars. The similarity in mass between the Venus-like world and its brown dwarf counterpart to Jupiter and its major moons, as well as the Sun and the outer gas giants, sparks intrigue. It hints at a shared origin for objects of diverse sizes, suggesting that moon formation from a circumplanetary disk akin to Jupiter's Galilean satellites might be a universal phenomenon if this discovery follows a similar trajectory. The recent discovery of an exovenus establishes a connection between planets and their moons. Specifically, the celestial body in question would be classified as an exomoon orbiting a star resembling a planet. According to Kipping, this discovery introduces a new constraint on the maximum size of moons relative to their host objects. For instance, a planet akin to Jupiter lacks the gravitational influence to foster the formation of a moon comparable in size to Earth within its orbital disk. Kipping argues that while massive entities can be captured, only a host as substantial as a brown dwarf can facilitate the creation of a moon on the scale of Earth or Venus. Understanding the boundaries of exomoons is crucial, particularly in the pursuit of habitable worlds, which serves as a primary motivation for astronomers. Although the large moons in our solar system are too distant from the Sun to sustain surface water, they remain promising candidates for alien life due to the presence of subsurface seas. Additionally, sizable exomoons orbiting distant gas giants might harbour surface water if they orbit close enough to their star, as suggested by researchers. While exomoons have yet to be discovered, space telescopes like NASA's Kepler are actively engaged in the search. Is it plausible for life to exist on a Venus-like planet? According to Gould, it seems improbable. Brown dwarfs, lacking core heat from fusion, are exceedingly cold, making it unlikely for this planet to be habitable given its distance from its star. Nonetheless, the method used to detect the dark planet around the dim star, known as microlensing, presents challenges for further research. This technique relies on the bending and magnification of light from a background star by the brown dwarf, enabling scientists to detect both the incredibly faint star and its accompanying orbiting planet. Observing planets orbiting brown dwarfs through methods other than microlensing presents significant challenges, although not insurmountable ones. Microlensing offers a unique advantage in detecting brown dwarfs even when they emit minimal light. However, the drawback lies in the inability to re-examine these planets to ascertain their atmospheric properties crucial for determining habitability. Microlensing relies on precise alignment with a background star, limiting researchers' ability to extract detailed information. Much like deducing a house's dimensions from its square footage, astronomers often lack sufficient data to differentiate between key parameters, such as mass, distance, and velocity, particularly in binary systems where two stars orbit each other. Nevertheless, astronomers typically possess additional data enabling them to deduce the mass of planets within such systems. Moreover, the newfound system is approximately 10 times closer to Earth than most known microlensed systems, facilitating a more detailed analysis of its signal fluctuations and, consequently, the determination of the planet's mass. NASA anticipates further microlensing detections in the future. Thank you for joining us on another episode of Cosmic Discovery. Before you go, be sure to check out the video on your screen for more captivating content on space exploration.